Welcome everyone. Question 4 from the AQA 2017 Paper 3 is like a greatest hits of acids and bases questions. Across these 9 marks, we're covering everything from the Ka expression to pH calculations as well as the half equivalence points. Take a quick photo of these questions now so you have them for reference later on. On the screen now is the stem of the question with all of the data that you'll need. Pause the video here and give these a go yourself first, then we'll walk through the answers together. The vertical section of the pH curve is the equivalence point. You should annotate this with a ruler and a sharp pencil. We can see that the vertical section lies between pH 7 and pH 10. This gains the first mark. Next, we have to give the Ka expression of a weak acid HX. A weak acid only partially dissociates. Molecules of HX are in equilibrium with H plus ions and the conjugate base X minus. Square brackets are used to represent concentrations. The concentration of H plus multiplied by the concentration of X minus is divided by the concentration of HX. Next, we have a moles calculation. Using the graph from earlier, we can see that 24 centimeters cubed of sodium hydroxide is required to reach the endpoint. The amount of hydroxide added to reach the endpoint is given by number of moles is equal to concentration multiplied by volume. The concentration of sodium hydroxide is given in the question, 0.100 mole per decimeter cubed. This is multiplied by the volume of hydroxide ions, but this must be in decimeters cubed, hence 24.0 times 10 to the minus 3. The amount of sodium hydroxide is equal to the amount of hydroxide ions. This works out to be 2.40 times 10 to the minus 3 mole. HX and OH minus react in a 1-to-1 ratio. The amount of HX present at the beginning of the reaction is equal to the amount of OH minus required for neutralization. This is equal to 2.40 times 10 to the minus 3 moles. To find the concentration of HX at the beginning of the reaction, divide the amount by volume. The volume of HX is given in the question, 25 centimeters cubed, which must also be converted to decimeters cubed. The concentration of HX in the original solution works out to be 0.0960 mole per decimeter cubed, and this gains the second mark. Next, we have a weak acid pH calculation. We can use H plus is equal to the square root of Ka multiplied by HX. This is a useful expression to memorize. We can use it when weak acids are present on their own, when the concentration of H plus is equal to the concentration of X minus. Recall that the concentration of HX at the beginning of the reaction is 0.0960 mole per decimeters cubed. We are given the value of Ka in the question. Substituting these numbers into the Ka expression gives us our first mark. The value works out to be 1.5859 times 10 to the minus 3 moles per decimeters cubed. Don't forget to square root. pH is equal to minus log to the base 10 of H plus concentration. This works out to be 2.80 and gains the second mark. Give pH answers to 2 decimal places unless the question states otherwise. The next question uses the idea of half equivalence points. At the start of a reaction, because HX is a weak acid, virtually none of it dissociates, so all of the HX is present as HX, virtually none of the conjugate base X minus is present, and none of the OH minus has been added. When half of the weak acid HX has reacted, half of it remains. For every mole of HX that reacts, 1 mole of X minus is produced. When half of HX has reacted, the concentration of HX is equal to the concentration of X minus. This is known as the half equivalence point. If we now look at the Ka expression, we can see that the concentration of X minus in the numerator is the same as the concentration of HX in the denominator, and these values cancel, so Ka is equal to the concentration of H plus. The p function simply means minus log to the base 10, so pH is minus log to the base 10 of H plus concentration, pKa is minus log to the base 10 of the Ka value. At the half equivalence point, pKa is equal to pH, therefore pH is equal to minus log to the base 10 of 2.62 times 10 to the minus 5, the Ka value. This works out to be 4.58. The final part of the question requires us to sketch the missing part of the curve. We can plot 2 points on the curve from the values calculated in previous parts of the question. The half-equivalence point occurs when half the volume of NaOH is added to reach the neutralization point, and we know that this value is 4.58. The initial pH of the weak acid is 2.80, so we can plot this value on the curve as well. These 2 points gain the first mark. To gain the second mark, the curve must pass through these points and be steeper at the beginning to show buffering. If that helped, watch this next video and subscribe for more chemistry explained. Any questions or topic requests, just post in the comments. Take care and good luck with your studies.